Hello and welcome. My name is Xander. I will be your instructor through this tutorial. Now, this tutorial is actually part of a whole course which you can access the first stages for free here on YouTube. Now, in this tutorial, I might mention resources and other tutorials. Do check out the link in the video description, which will take you to the playlist, and also there will be a link to the resources so that you can access and follow along here on YouTube. Now, if you like this course, you found it useful, and you want to take that next step, you can find this course over at Udemy. All the links to the resources can be found in the video description. Now, don't forget, also subscribe to the channel for weekly promotions, discounts, and free course giveaways. In this tutorial, we'll learn how to build a many-to-many relationship between two tables in our Postgres database using SQL. A many-to-many relationship occurs when multiple records in one table are related to multiple records in another table. Taking a look at our ERD, we have two instances of this: products and orders, and products and promotion events. And you can see in each instance, we create what I call a link table. This is also called a bridge table or an association table. And some others might call it a through table. Through this database design process, we have determined that we needed a products entity and a promotion events entity. And then we went through the process of identifying the relationship between the tables. So starting from the product side, one product is related to multiple events or potentially multiple promotions. Okay, so we have one-to-many between products and promotion events. So one promotion event might include multiple products. So from both sides, we have a one-to-many relationship, thus creating a many-to-many relationship between the two tables. So that essentially means we need to be able to record products and their promotion events that they are associated to. And that can't be achieved within the products or promotion event table, because if it was in the products table and we had just a foreign key, that foreign key would potentially have multiple values in that one field. And that is something that we try to avoid when designing a database field or providing a database field. The field should only have one value. So having a link table, or a link table, I call it a link table. Like I said, it could also be known as a bridge table, association table, or through table. This link table enables us to actually model the data, the relationship between products and promotion events, without duplicating data or without having to actually insert data into a field where we would need to supply two or more values. Now, if we take a closer look at one of our link tables between the many-to-many relationship we have here between products and promotion events, you can see what is in this table is just one primary key, and two foreign keys referencing the related tables. Right, so let's take a look at how we're going to create this in our Postgres database using SQL. Right, so let's start with viewing all of the tables that we have to make sure we have the products promotion events table, the link table or through table. Okay, so we do. So we can further inspect that to see how far we got with creating that. So it looks like we have some sort of primary key set in that table. Okay, so the first task is to create the two fields, product ID and product promotion event ID, the two foreign keys. We've learned that previously, so alter table, add some new columns. We've assigned that to integer field types. Okay, doesn't exist because we need plural. I've accidentally not added the plural there. So that's now created. So we can have a look at that. So we now have the fields in place, product ID and promotion event ID. Now, ideally, we want to make sure that both fields are set to not null, because we don't want to have a case where we reference a product ID foreign key, but not the promotion event ID. That wouldn't create any valid data in our case. It'd be pretty useless. So let's, like we've done previously, add the not null to the fields Let me just do that again. Okay, so now we have not null assigned to both fields. So now we can add the foreign key constraints. And this time we're going to use the cascade option, and I'll explain that shortly. So let's go ahead and add the first foreign key constraint. This is going to be to product ID. So our constraint, the foreign key, that's the field we just created, product ID. And of course, we want to relate that foreign key over to the product table and the primary key field in that table. And we set the onDelete to cascade. Right, so that's the first of the two foreign keys. And then we can add the second over to promotion events this time. Same principle again, adding the foreign key, referencing the promotion events table and the primary key in that table. Okay, so it tells me that product does not exist. 1 second. So it looks like I made a mistake here. Okay, so let's make some changes here. So we actually, so let's add the first. Okay, so I forgot the semicolon. So that's altered the table to update the foreign key constraint for the product side. And now let's do the other side. So we're going to need to alter the table again because we have executed the previous command. So let's perform the same task again now for the second. And there we go. So now when we have a look at the table, we should now have our two foreign key constraints over to the respective tables. So why cascade? Why, if I delete a product, would I want to delete the reference in the promotion event? Well, because the product doesn't exist anymore. So it makes perfect sense. If I delete a product, I also want to delete the reference to the fact it's in a promotion. So if I delete product, I want to delete the related record in the product promotion event table. If I delete the promotion, I also want to delete all the related records in the product promotion events link table here, because that promotion no longer exists. So it doesn't make any sense for the data to exist anymore potentially in the link table. So in this case, we're going to use cascade. Cascade for the onDelete behavior. Now there's going to be one more action that we need to take here, and that is because we want to ensure that we don't duplicate in this table. We don't want there to be a duplicate product ID and promotion event ID in this table, because that would mean that we have accidentally duplicated the same data. So in this link table, we have at the moment a primary key, say 1. So we have 2 records, say primary key, and then we have the product. So we have the product reference. So let's say product number 1, and then we have the actual sale or promotion. So the promotion ID. So let's say this is promotion number 1, which is related to some sort of maybe winter promotion, okay, in the promotion table. What we don't want is an instance where we accidentally add product 1 again and promotion 1, because we've simply just replicated data that already exists. So we shouldn't be able to do that. So to avoid this in the link table, we would typically set up a uniqueness to ensure that product and promotion in this case are unique together. So at no instance in this table should product and promotion be replicated in any records in our database. So we want to prevent that by ring fencing both product and promotion to be unique together. So we have 2 options. We can enforce uniqueness on a combination of product ID and promotion event ID. For that, we would need to add a unique constraint, or potentially we could define a composite primary key of both product ID and promotion ID. In this scenario, we're going to show you how to add a unique constraint on both product and promotion. Now, I think we have used unique previously in another table. Here we simply just need to alter the table product promotions events to add a new constraint. And that's going to be called product promotion event or product promotion event unique. And we need to supply the fields that we want to combine together to specify that that data in those fields must be unique throughout the whole table. Okay, so let's alter the table. That should now be set, and we can go ahead and view that, and that should now be set here. So we have a unique constraint on both product ID and promotion event ID. So as we've seen in this tutorial, a many-to-many relationship occurs when multiple records in one table relate to multiple records in another table. So since databases don't support direct many-to-many relationships, we use a junction or link table to connect them. So in this tutorial, we used a junction or link table to handle many-to-many relationships. We used foreign keys to maintain that referential integrity between the corresponding tables, and we added a unique constraint or composite primary key in some cases to prevent duplicates. And then remember, in this scenario, we use the onDelete cascade to automatically delete the related records when the parent is removed.